Hello everyone, welcome to my channel Cyber Hashira. So far, I've been showing you how to generate keys and then use them for signing or encryption. My sample codes were generating objects as session objects. So today I will show you how to reuse a key stored in a token instead of generating a new one each time we run a code. Let's see how it's done. These are the three functions that I will be talking about in this video. I'll start with find objects init. If you see init in the name of a function in PKCS11, it usually means that that function is meant to initialize something. The find objects init function is meant to initialize a search for an object. So when you're searching for an object such as a key or a certificate, you must always start with find objects init. This function requires 3 arguments. Like many other PKCS11 functions, the first argument is a session handle. The second argument is a template that will be used to perform a search. The template may contain one or more attributes that will be used to search for a specific object. Stay with me, I'll explain how this works in a minute. And the third argument is the length of that template. This is usually the number of attributes present in the search template. And these are some of the return codes that find objects init function may return. You can read about find objects init on page 136 and 137. I will now explain what search templates are. Imagine search templates to be kind of like a SQL query where you describe what you're searching for. In PKCS11, a search template contains the attributes that find objects function would use to search for an object. What you see on your screen are 5 examples, starting from the easiest to a bit more complex search. The first example is easy to understand. There is only one attribute, CKA token, which is set as CK true. This search template would instruct find objects init to look for all token objects. In the second example, there are 2 attributes, CKA token set as true and CKA class set to CKO private key. This template would search for all token objects that are private keys. In the third example, there are 2 attributes defined in the search template, CKA private set as true and CKA key type set to CKKAS. By the way, if you are unfamiliar with these attributes, then please watch the video I made about PKCS11 attributes. In this example, the find objects function would look for all private objects that are AES keys. In the fourth example, there are 2 attributes, CKA label with encryption key as its value and CKA ID with A1, B2, C3, D4 as its value. This search template would look for an object with the label encryption key and A1, B2, C3, D4 set as ID. In the fifth example, the search template contains 4 attributes, CKA key type set to CKK RSA, CKA class set to CKO private key, CKA modulus bit set to 2048, and CKA sign set as true. So this template would search for a private key of type RSA with a key size of 2048 and sign attribute set as true. After find objects init function has initialized the search, find objects function continues to look for those objects. If there are too many objects present in a token, then this function can be repeated multiple times till your application finds the object it was searching for. find objects function requires 4 arguments. First argument is a session handle. The second argument is of type CK object handle. This is a variable which would receive the list of all objects matching the search template. The third argument is the maximum number of objects you want find objects function to search for at a time. For example, if this value is set to 10, then find objects would search for a maximum of 10 matching objects at a time. And after searching through the list of all objects in a token, cFindObjects returns the count of how many objects were found. The fourth argument specifies the location where that value will be written. These are the return codes that cFindObjects function is expected to return. You can read about cFindObjects on page 137 and 138. And the last function for this video is cFindObjectsFinal. You use it to tell CryptoKey that you have finished searching for an object. When you use this function, CryptoKey will clear out the memory it used when you started the search with cFindObjects in it. So it is a good practice to call this function at the end of a search. This function only needs one argument, the session handle. It should be the same session handle used when you started the search with cFindObjects in it. These are the return codes that cFindObjectsFinal may return. You can read about cFindObjectsFinal on page 137 and 138. Okay, for this video, I have prepared two sample codes. So now I will take you to my Linux machine and explain how that code works. Okay, so these are the two samples that I prepared for this video: count all keys and find private key to sign. I will start with count all keys. Okay, so here's the code. Now this code will use cFindObjects function to count the number of keys present in a token. So executing this code will display a count of all keys present in a token. It will display a count of all ECC private keys present in a token. It will display a count of all RSA public keys present in a token. And it's going to display a list of all secret keys. Now I'm not going to explain the entire code, so I'll just go directly to the function that performs these tasks. So these are the four functions that I've written. And okay, here's the first function. Okay, so here's the count all objects function. This function is supposed to use cFindObjects to search for all token objects in a token. Here's the template that cFindObjects will be using. As you can see, I have only mentioned one attribute in this template, which is CKA token. The value is set to yes, and yes has a value of CK true, which means cFindObjects will look for objects that are token objects. Let's have a look at the first PKCS11 function executed in this sample. So the first function that I will be executing is cFindObjects init. This function is going to initialize the search. The three arguments it takes: a session handle, the attribute, here's the attribute template, and the length of that attribute. Now, because I have only set one attribute in this template, the value of attrib len is going to be 1. And then I'm using a do while loop. So it will keep searching for objects. Inside this do while loop, I am calling cFindObjects function. This function takes 4 arguments: the session handle, the object handle in this case is this variable. It is an array of size 10. And I want cFindObjects to search for 10 objects at a time. And once it has searched for all objects, I want the count of those objects to be stored in objcount variable. Objcount is of type CKUlong. And after this loop has counted all the objects, it will then call cFindObjectsFinal function with the session handle. So this is telling CryptoKey to end the search. And then CryptoKey will release the memory that it initialized when we called cFindObjectsInit function. And that's the inner working of count all objects function. Okay, let's move on to our next function. And that is void count private keys. Okay, so count private keys function is supposed to search for all ECDSA private keys present in a token. Here's the search template that cFindObjectsInit function will be using. This template has 3 arguments, or I should say 3 attributes. The first attribute is CKA token. The value is yes. Yes has a value of CK true, which means cFindObjects will be looking for all token objects. The second attribute is CKA class. It is using obj class variable. Obj class has a value of CKO private key, which means the search will be limited to just private keys. And then there's a third attribute called CKA key type. This is using obj type variable. Obj type is set to CKKAS. So in summary, this template is supposed to look for token objects that are private keys and of type ECDSA or EC. And then here's the cFindObjectsInit function. This function is taking 3 arguments. The first argument is a session handle. Second one is the search template. Here's the search template, and then the length of this template. So the length of this template is going to be 1, 2, and 3. And then here's the do while loop. Inside the do while loop, I have cFindObjects function. The 4 arguments passed in this function are the session handle, the object handle. Here's the object handle variable. It is an array of size 10. I want cFindObjects to search for 10 objects at a time. And once it has found those objects, I want the count of those objects to be stored in a variable called objCount of type CKUlong. And after it has finished searching for all those objects, I am calling cFindObjects final function here to end that search. And then it's going to display the number of ECC private keys it found inside the token. And that's the working of count private keys function. Let's move on to our third function. Okay, here it is, void count public keys. Okay, count public keys function is similar to the previous function that I talked about, count private keys. So I'll just talk about the differences. There are just 2 differences. CKA class is set to CKO public key, which means I want the search to be limited to public keys. And then CKA key type, which is using obj type variable. This variable is set to CKK RSA, which means this search template will look for token objects that are public key and of type RSA. And then here's our usual cFindObjectsInit, the do while the do while loop, and inside the do while loop we have the cFindObjects function. And once the findObjects function has finished searching for all objects, it will call cFindObjects final function to end that search. And it will display the number of RSA public keys found in a token. Let's move on to our next function. And the next function is count secret keys. Okay, so this function is supposed to search for all AES keys present in a token. And this is the search template that it will be using. So CKA token is set to yes. Yes, as we know, is set to CKA true. CKA class is using obj class variable, and obj class is set to CKO secret key, which means the search will be limited to just secret keys. And then the third attribute, CKA key type, is using obj type variable, and obj type has a value of CKKAS. So in summary, this template will be used to search for all token objects that are AES secret keys. And then here's the same cFindObjectsInit function, the do while loop, the findObjects function inside that loop, and then cFindObjects final function to end the search. And after the search has ended, it's going to display the number of AES keys found in that token. Okay, so those are the 4 functions that I am using, and Here it is. I will be calling them inside the main function. I will now take you to the terminal and execute this code. Okay, so first I will compile this code. So to compile, g++ count, output this into count, include all headers in the include directory, and this is for Linux, Unix. Okay. Okay, I need the slot number. Here's a slot number. So now count in this token, and here's the password. 0000. Okay, so it looks like there are no objects in the token. Let's verify using P11 tool. So the library is in user lib, SoftHSM, list all, login. Oh. Yep, so it says no matching objects. All right, so let's try this. I'm going to generate some objects. I'm going to generate an RSA key first. So P11 tool, generate private key, RSA -- bits. So RSA key of size 2048. And I will also give it a label. I'll call it RSA01. Okay. Okay, here's our first RSA key. Let's create one more. That's the second RSA private key. Let's generate an ECDSA key pair. So ECDSA01, and this is going to use curve SECP 256 R1, and what else? Oh, ECDSA. Okay. That's the first key pair. Let's generate one more, or one is enough. Okay, let's execute the sample code again. Okay, so now it says it found 6 objects, 1 ECC private key, 2 RSA public key, and it did not find any AES key. Let's generate an AES key and see if this sample works or not. Okay, to generate AES key, I will have to use PKCS11 tool utility. So PKCS11 tool key gen -- key type of AES with the size of let's try 16. And the module that I want to use is in user lib SoftHSM, lib SoftHSM, and I want to log in. Okay. AES key generated. Let's execute this sample. And now it found an AES key. Let's generate one more. Okay. And now it found 2 AES keys. Okay, I hope this is clear. Let's move on to our next sample. Okay, our next sample is find private key to sign. Let's have a look. Here it is. So this function will use cFindObjects function to find a private key in a token, and then it will use that private key to sign some data. And once the data has been signed, it will write the signature onto a file. Now, if you need help to generate the private key, I have provided the command. So this command would generate RSA private key of size 2048 with a label my signing key, and it will output the public key for verification purpose onto a file named verification.pub. This is how I would generate a text file. And here's the command to verify the signature. If the signature is a success, you would see signature verified successfully. And just in case if the verification fails, then you would see this message, signature verification failure. We will be using OpenSSL utility to verify the signature generated by our PKCS11 code. Let's have a look at the functions. So in this code, there are three functions. There's void find signing key, sign data, and write signature. Find signing key is supposed to find the private key. Sign data will use that private key to sign the data, and then write signature will write that signature onto a file. Here's the data that this sample code will be signing. Earth is the third planet of our solar system. Let's scroll down. Okay, so here's find signing key function. Okay, so find signing key is supposed to find the private key, which will be used for signing the data. Here's a search template. Inside this template, I am passing two attributes. The first attribute is CKA class. I am passing obj class variable into it. The value of obj class is CKO private key, which means the search will be limited to just private key. The second attribute that I'm passing is CKA label. Now, when I execute this code, I will be passing the label of the private key that I want to use. And that label will be used to search for that private key here. Okay, and then I'm calling cFindObjectsInit function. I'm passing the session handle, the attribute template or the search template, and then the length of that template or attrib len. There are just two attributes in this template, so the value of attrib length is going to be 2. The next function to be executed is cFindObjects. This is the function that will search for that private key, and once the search has completed, I will be calling cFindObjects final function to tell CryptoKey that I'm ending the search. Okay, after the search, there's a check here that checks for the value of object count. If the object count is 0, it will display private not found or private key not found. So here's object count. Just in case if the private key is found, then the value of obj count would be more than 1. If the private key is indeed found, then it will display the label of that private key and it will write the message found, and it will begin signing the data. So let's go ahead and look at sign data function. Okay, so inside the sign data function, I have written the code to sign that data. I will be using CKM SHA-256 RSA PKCS, which is equivalent to SHA-256 with RSA mechanism. I have previously made a video about signing, so I will not be discussing sign init and sign function. So once the data has been signed, it will call our next function, which is write signature. So let's go ahead and look at our next function. Here's write signature. So this function will write the signature of that data onto a file with the label signature_file. And after the signature has been written, the program is going to end. So here's find signing key function. Okay, I'm going to compile and execute this code. Okay, before compiling and executing that code, I would first generate a private key. So generate priv key of type RSA, size of 2048, and I'll just give it a label. Let's call it signing key 1, and out file This is where I will write the public key. So I'll just name it key1.pub. Okay. Oh, come on. Okay. Let's generate another one. So sign2 and key2. Okay, so I have generated two private keys. I will be using one of them for signing that data. Let's compile our code first. And to compile, I would run the command g++ find, output this into find this file, include unix. Okay. Okay, this is the slot number that I want to use. Okay, so the slot number, normal user, this is the crypto, or I should say the user password. And the label is signing key 1. Okay, so it says signing key found, data signed. And here's the signature file. Let's verify the signature. So to verify the signature, I would run the command openSSL pkeyutil -verify. Input is, oh, wait a minute, I have not created the file. So Earth is the third planet of our solar system. This goes into earth.txt. Okay, clear the screen. Okay, so openSSL pkeyutil I want to verify. Input is earth.txt. This is a file that I want to verify. Take it as raw input. In key. I'm going to use key1.pub. This is the public key associated with the private key, which I used for signing. And I'm going to tell openSSL that it is a public key. And the signature file is this one, signature_file. And it says verification successful. Let's see what would happen if I were to pass another public key. So I'm going to pass key2.pub. So this is a public key which is not actually associated with the signing key that I used for signing the data. So in this case, the verification should fail. And indeed, it says signature verification failure. That's all for this video. I hope you learned how to use an existing key in a token for cryptographic operations. If you have any questions, feel free to leave them in the comment section below. I'll be happy to answer them. You can find the sample codes I used in this video on my GitHub page. The link is in the description below. I hope you found this video informative. If you enjoyed it, please consider giving it a thumbs up and subscribing to my channel if you haven't already. I will talk to you soon in another video. Take care. Bye bye.